Ocean acidification is bad, and it's happening right now. Let's talk about it. Each year, the ocean is becoming more and more acidic. Although most sea creatures are affected, shelled creatures are becoming especially weak. Habitat for most ocean life is at risk. Not only does ocean acidification affect the creatures already living, but it is stunting the growth of shellfish, making it harder for them to grow shells and maintain their health. This is only the beginning. Each year, the ocean absorbs 25% of the CO2 we produce. When it reacts with the CO2, carbonic acid ions are formed. As more CO2 is absorbed, the pH of the ocean goes down, therefore becoming more acidic.
How do we know that the ocean is becoming more acidic, and what does it mean when the pH goes down? To start off, we must first understand what it means to be acidic. All substances are either acidic or basic. Acids produce H+ ions when dissociating in water, and bases bond to H+ ions. H+ ions are produced when CO2 is absorbed by the water, making it an acid and not a base. To figure out whether a substance is acidic or not, we use the pH scale. The pH scale starts at 0, which is the most acidic. A substance with a pH of 7 is neutral, and a substance with a pH of 14 is the most basic. More acidic substances have a higher concentration of H+ ions, and opposite of that, more basic substances have a lower concentration of H+ ions. On this scale, the H+ ion concentration decreases by 10 for every 1 increase in pH. The carbonic acid formed when CO2 is absorbed by the ocean water is broken up into H+ ions and bicarbonate ions. The bicarbonate ions are then broken up into more H+ ions and carbonate ions. All these equations are in equilibrium with each other, which means that they are reversible.
So, how does the acidification of the ocean affect marine life? Marine life, such as coral, use calcium carbonate to form its skeleton. Without it, the skeleton dissolves. This is true for many other shellfish and marine life. Calcium carbonate is made up of Ca2+ and CO3 2-. The living corals in the water need the calcium carbonate that the dead corals are giving off in order to strengthen their own skeletons, but the H+ ions that are produced from the breakdown of bicarbonate ions want to bond with the carbonate part of calcium carbonate in order to produce more bicarbonate. This is an example of an equilibrium reaction because the products of the breakdown of bicarbonate are reversing to form more bicarbonate. The more bicarbonate that is formed from the CO2 in the water, the more that it continues to break down into H+ and CO3, and the whole process of the CO3 from the dead sea life bonding to the H+ ions instead of calcium repeats itself. Slowly, these reactions cause the shells of the marine life in the water to dissolve.